on to lesson 3.1, factoring polynomial expressions. The kinds of expressions I'm talking about here are going to be of the form ax squared plus bx plus c. If a trinomial does not have a common factor, then it factors. If they exist, they will be two binomials. So let's look at some examples of that. Example 1. Is y minus 4 a factor of each trinomial? Justify the answer. So we want to know if y minus 4 is a factor, then y minus 4 will be a binomial, as so, that multiplies by another binomial of the form ay plus b in this case, to distribute out to equal the trinomial 2y squared plus 6y minus 56. So we can say that 2y squared plus 6y minus 56 equals our y minus 4 times our ay minus plus b binomial here. So let's go ahead and distribute those two binomials, and we're going to get 2y squared plus 6y minus 56, and we'll have ay squared plus a y onto what will be minus 4a plus b when we distribute that out. And our last will be minus 4. So comparing these two, you can notice that our 2y squared and our ay squared are supposed to match up. So we can say that our a equals 2 in this case. But we need to find the value for b as well to complete our binomials. So let's substitute. And we'll have the fact that our 6y should match up with this y onto 4 minus 4ab plus minus 4a plus b. So let's say that 6 equals minus 4a plus b. Plugging in our a, we get 6 equals minus 4 times 2 plus b. 6 equals minus 8 plus b. And solving for b, we get 6 plus 8 equals b, which comes out 14 equaling b here. But let's check to see if we did our work correctly. We're checking our binomial y minus 4 times our new binomial of 2y plus 14. And we need to distribute that out to see if it matches our original trinomial. So let's distribute. Y onto 2y plus 14 minus 4 times 2y plus 14. 2y squared plus 14y minus 8y minus 56. Collecting like terms, we get 2y squared plus 6y minus 56. And that does match our original trinomial. Everything worked out correctly. Awesome, let's try another one. So here we're still wondering if y minus 4 is a factor. So we want to know if y minus 4 times another binomial of the form ay plus b will create our trinomial of 3y squared plus 13y plus 4. So we want 3y squared plus 13y plus 4 to equal our y minus 4 times our ay plus b. Distributing, we get 3y squared plus 13y plus 4 staying the same, and we have ay squared plus y onto minus 4a plus b minus 4b. Comparing our terms again here, we can decide that our a equals 3. So we want to substitute. We'll sub the fact that our 13 should equal our minus 4a plus our b. So 13 equals minus 4a plus b. Subbing in for a, we get 13 equals minus 4 times 3 plus b. 13 equals minus 12 plus b. And solving for b, we get 13 plus 12 equals b. And 25 equals b as our solution for b. But we need to check, see if we did our work correctly. So we have y minus 4 times 3y plus 25. Let's see if that will distribute out to have our original trinomial. Y onto 3y plus 25 minus 4 onto 3y plus 25. We get 3y squared plus 25y minus 12y minus 100. And that becomes 3y squared plus 13y minus 100. And this does not match up here. So we can say that no, y minus 4 is not a factor. Let's see what else we have. Example 2. Factor each trinomial. So now it wants us to find the two binomials that multiply together to get the trinomial that we're given here. A. X squared minus 1.5x plus 0.5. Well, here we're given decimals, and those aren't very easy to factor. So we're going to go ahead and take out a common factor of 0.1, so that way we can work with integer values. And we do that by multiplying by 10. So this gives us 0.1 onto 10x squared minus 15x plus 5. And here I notice that we have another common factor of 5. So now we have 0.5 times 2x squared minus 3x plus 1. Now to factor this trinomial, we're going to use what I call the AC method to determine what our factored values are going to be. So our AC method takes our A coefficient and multiplies it by our C coefficient, which in this case will give us 2 times 1, which equals 2. So we need now to find two values that will multiply to 2 and then we'll add to 3 here. So factors of 2 are 1 and 2, and that is all we have in this case, and those also add up to 3. So now we're going to rewrite our equation and split our central term of 3 into 2 and 1 equals 2x squared minus 2x minus x plus 1. At this point, I'm going to split our expression in half so I can simplify each individually. And we're going to get our first expression. We can factor out a 2x, and we're left with x minus 1. And our second expression, we can take out a minus 1 to be left with x minus 1. Now this is exactly what we wanted to have, because we wanted our two binomials here to match up. If they did, that shows that we did our work correctly, and now we have two factors of our x minus our 1 and what's left over, which is our 2x minus 1. And there we have successfully factored the trinomial that we were given. But we did take out a common factor of 0.5, so we should include that 0.5 back into our factors as so. 0.5 times x minus 1 times 2x minus 1. And that there is our final answer for our factoring. Alright, let's do another one for practice. B. X squared minus 17 over 3x minus 2. So here we're given a fraction in our central coefficient, and we don't want to work with that, so we're going to take out a common factor of 1/3, so that way we can work with integer coefficients. So that means we need to multiply by 3 here. So we're going to get 1/3 onto 3x squared minus 17x minus 6 as a new trinomial. Using the AC method, we're going to have 3 times negative 6. 3 times negative 6, which will equal negative 18. So now we need to find two factors that will multiply to become negative 18, but will subtract to become 17. Factors of negative 18 are negative 1 and 18, 1 and negative 18, 3 and negative 6, negative 3 and 6, 2 and negative 9, and negative 2 and 9. Looking at these factors, I see one pairing that will add to become negative 17, which is 1 and negative 17. We can go ahead now and include those factors into our expression by going 3x squared minus 18x plus x minus 6. So now I'm going to go ahead and split the equation like I did before, and we're going to factor out, and we'll find that we can factor a 3x out of this equation, and we're left with x minus 6. And this one, we can only factor out a 1 and being left with x minus 6. Our binomials are the same, hence our factors are going to be x minus 6 and whatever's left over, which is 3x plus 1. But we need to include what we took out as a common factor earlier, which is 1/3 onto x minus 6 times 3x plus 1, leaving us with our final answer of 1/3 times x minus 6 times 3x plus 1. Do some more practice. Some polynomial expressions contain functions of a variable. For example, an expression such as x plus 3 squared minus 6 onto x plus 3 minus 16 contains f of x equals x plus 3. Hence, the above equation has the form f of x squared minus 6 times f of x minus 16. So instead of having a variable, we can have a variable function. Let's look at some examples. Example 3. Factor each polynomial expression. Alright, first thing we need to find is our AC, which is 1 times negative 12, which will give us negative 12. What numbers multiply to get negative 12 and add to negative 1? Let's see, we have negative 12 and 1, 12 and negative 1, 2 and negative 6, negative 2 and 6, 3 and negative 4, and 4 and negative 3. Of these choices, I think the best suited here will be 4 and negative 3, multiplying to negative 12 and adding to negative 1. Alright, let's include those in our polynomial expression. Now we're going to have x squared plus 3x minus 4x minus 12. Splitting the equation, we'll find that we can factor out an x from here, leaving us with x plus 3, and a negative 4 from here, leaving us with x plus 3. So our factors here will be x plus 3 and x minus 4. Perfect.